Images may be formed using mirrors and lenses. First, let's look at image formation using mirrors. Images may be formed using mirrors and lenses. Images or optical copies of an object may be formed using reflected light or refracted light. When reflected light intersect or when refracted light intersect, at the point of intersection, an image or optical copy is formed. When actual reflected light or actual refracted light intersect, the image that may be formed is called the real image. But when the image is perceived to have formed, but there is no actual reflected light or actual refracted light in the location where the image is perceived, the image is called a virtual image. For instance, if you look at the diagram or picture shown, you have a candle, light from the candle reflects off a mirror and is seen by a person. Now, from the point of view of the person, the image formed by the candle is inside or behind the reflecting surface, inside the mirror. The image of the candle as shown in the picture. Now, since reflected light is in front of the mirror and the image is behind the mirror, the image formed where there are no reflected light. Thus, the image formed is a virtual image. Now, a mirror is an optical device that reflects light. Thus, a mirror uses reflected light to form images. The location of the image with respect to the mirror and with respect to the object itself is described by the following equation. 1 over s plus 1 over s prime is equal to 1 over f is equal to 2 over r. S is location of the object from the mirror with respect to the mirror. Is referred to as the object distance. S prime is location of the image with respect to the mirror, referred to as image distance. F is location of what is called the focal point of the mirror, and it is again just like S and S prime with respect to the mirror, location of the focal point from the mirror. F is called the focal length of the mirror. R is radius of curvature of the mirror. The object distance, S, may be positive or it may be negative. S is positive if the object is in front of the mirror, while it is negative if the object is behind the mirror. Now, typically, the object is in front of the mirror. Typically, S is positive. This is particularly true for a system that has only one optical element. In this case, the system is comprised only of one mirror, the object and one mirror. Now, S may be negative. This is particularly applicable or might be applicable to a system that has more than one optical element. The system might be comprised of more than one mirror or more than one lens or a combination of mirrors and lenses. There's a chance that the object will be behind the mirror, in which case S is negative. This is also applicable. S is equal to negative may also be applicable if the object that we are talking about is an image formed by another optical element. Since the image is just an optical copy, it may be behind the mirror. Unlike a actual physical object, which is impossible to be inside or behind the mirror. But an optical copy, it is possible. S prime, the image distance, likewise may be positive or it may be negative. S prime is positive if the image is formed in front of the mirror, and we refer to this image as a real image. It stands to reason that for a mirror, real image is in front of the mirror because a mirror uses reflected light to form images, and if the reflected light is in front of the mirror, therefore the real image must be in front of the mirror as well. And S prime is negative if the image formed is behind the mirror. The image is referred to as a virtual image. So again, S prime positive, you have real image. S prime negative, you have virtual image. F is the focal length, and it can also be positive and negative. F is positive if in front of the mirror, and negative if the focal point is behind the mirror. The same applies for the radius of curvature. If the radius of curvature is in front of the mirror, R is positive, whereas if the radius of curvature is behind the mirror, R is negative. We also have the following equation. M is equal to negative S prime over S is equal to H prime over H. M is referred to as the lateral magnification of the image. The image may be smaller or bigger than the object, and that is reflected by the magnification M. M may be positive or negative. If M is positive, the image is erect or has the same orientation as the object. And if M is negative, the image is inverted or has the opposite orientation as the object. H is called the object height and is always positive, whereas H prime is referred to as the image height, and compared to the object, H prime may be positive or may be negative. H prime is positive if the image is erect, and negative if the image is inverted. Now, there are two types of mirrors to speak of: flat mirror and spherical mirror. Flat mirror or plane mirror, you have a flat reflecting surface. We can consider the radius of curvature of the mirror to be infinite, which means the focal length, which is half the radius of curvature of the mirror, half of infinite is still infinite, so we can say the focal length of a flat mirror to be infinite. Applying this to our equation of focal length, image distance, and object distance, we get that the image distance S prime is just equal to negative S. For a flat mirror, the tendency of the image formed is a virtual image. Now, in terms of the spherical or curved mirror, the reflecting surface is curved, there are two types of curved mirrors. You have the concave mirror and the convex mirror. So first, let's look at the concave mirror. For the concave mirror, the curvature is such that the radius the radius of curvature is in front of the reflecting surface. Thus, R is positive, which means the focal length is also positive. So it doesn't matter where the object is located. For a concave mirror, automatically R and F are both positive. And for a convex mirror, you have the opposite. If the concave mirror, you have R and F to be positive. For the convex mirror, the radius of curvature of the reflecting surface is such that the radius is behind the reflecting surface. That is to say, R is negative, which means F, the focal length, is also negative. So for a concave mirror, R and F are positive. For a convex mirror, R and F are negative. And that's it for now. In the next video, we'll talk about image formation using lenses.